welcome everyone to the Flyte community presentation. David Espejo. Been part of the community for quite some time, and I'm also with Union AI, one of the main contributors to the project. Coming to you today in the Flyte and Union social media accounts. According to this, we are already live, so that shouldn't be an issue. Let me see. There you go. Yeah, we are live. Cool. So if it's your first time here, Flyte is an open source project hosted the Linux AI and Data Foundation. It's a graduate project there. With an open governance model that essentially allows anyone to contribute to the code in docs. And also, this is what you see today is also a very valid form of contribution when you kind of accept the invite and come up to share with the rest of the community how you're using Flyte, and that is the case today. Couple of PSAs of public service announcements. We had a kind of recent release in Flyte. Let me drop the link here just in case you haven't taken a look. Kind of new things, a couple improvements to the array node, say internal implementation. Array node is essentially the way Flyte implement map tasks, and map task is one of the main constructs in Flyte to do parallelism in a way that you can essentially concurrently map over a list of inputs instead of just waiting for processing an input and then going to the next one in a serial manner. So it's great to achieve efficiencies without having to install or configure any other parallel computing framework. And we had some improvements there and also some fixes, including one that was bugging me personally. And it was if you follow the docs for configuring Flyte to send to send execution events to Kafka, to Apache Kafka, there was no error and there were no events. It was pretty strange, hard to debug. Essentially, there were some opinions in the way this implementation was expected in the configuration. This is now fixed, so you can feel free to follow the docs, and it should work if you're using Apache Kafka for events. Awesome. And we have another event coming up this week. Dropping the link here in the comments. It's also under Union AI's LinkedIn account. It will be a workshop on all things parallelism, kind of how can you go and what are the implications of going from regular serial processing, serial pipelines to different levels of parallelism in Flyte, and also how Union extend this a bit further. So it will be purely live coding. We'll be hacking with the Flyte cluster and also a Union cluster, almost breaking it with the level of parallelism we're trying to achieve. So we hope you learn something new if you join. If not, you can also watch the recording. And this is the case for this presentation. It's automatically available under Flyte's YouTube account. If you have any question after the presentation, just feel free to go to the Flyte Slack workspace. Okay, so without any further ado, welcome Ratnakar. You've been an awesome Flyte user, and we really thank you for stepping up and accepting the invite to be here. So welcome.
Yeah, thank you, David.
Cool. So I will add your screen sharing. And yeah, it's all yours.
All right. Hello, everyone. Again, thank you, David, for giving me this opportunity to speak about our experience working using Flyte at Pathomiq. My name is Ratna Karmala. I'm a VP of Engineering here at Pathomiq. And who we are? Pathomiq is we are a AI first company where we in the medical medtech space where we take digital pathology images, uh, uh, which are and then build we extract clinical biomarkers for cancer and other things from those digital pathology images. Right? Uh, our team includes machine learning engineers, data scientists, domain experts, and of course, backend and front-end software engineering people. We just recently announced a test for prostate cancer that will be launching at the end of this year. It's AI-based. So, how does our digital pathology workflow work? Say, imagine that your doctor suspects cancer. They take a sample of tissue from your body. They send it to the lab. The lab, the pathologist actually processes that sample and then looks under the microscope, looking for uh, any indications for cancer, how far you are in the cancer, and things like that. So that's the normal traditional workflow. But now those images are being scanned and digitized, like the rest of the other things happening in the world. So they're being digitized. Now, once it's digitized, it's available for you to run any machine learning algorithms or anything processing that you want to do. So that is the idea here. So what we do is we take those ultra high resolution images. These images are scanned at 40x zoom. So these are gigapixel images. So with ultra high resolution, those images are scanned. Those scanned images are ingested into our pipeline. And once they're ingested in pipeline, we have a team of experts that they go in and annotate different areas of cancer, and they categorize what type of tissue is that, and they do the traditional pathologist workflow there, identify different areas and the like. Those regions of interest are then used to fed into the to train our machine learning models, right? And this is a feedback loop. We continue working on this until we achieve our desired scores. So this is again traditional machine learning pipeline. I would hope nobody is surprised with this. We have a huge amount of data that's in our S3 buckets that we collected over the last couple of years. And that data is fed into the ingestion pipeline. We do basic, and then as well as do data preparation on the data. And those, as I said, those images, the gigapixel images are then tiled into smaller 256 by 256 tiles, and those tiles are fed into the training loop. Once the model has been trained and evaluated, we put it in the model registry that's available. Then it's further available for the inference pipeline. So this is typically how the inference pipeline will work. So this at the top left, you see this is the one typical digital pathology scan that our customers send, and that is basically this broken up into tiles, and those tiles are then fed into the encoder, which will extract the embeddings. And using that, as well as our own proprietary features, we calculate the outcome of the patient, or what's the risk for a certain cancer or other biomarker features. And one important thing that we have is that our features are machine interpretable. So the pathologist, who is our main user, can go in and look at why we arrived at that score. So you can see it will highlight in the cancer area where in the scan well different areas and what's the risk, and the pathologist can validate themselves that the algorithm has arrived at the right solution. So that's a key feature for our platform. So again, so this is our pipeline, how we set up our infrastructure. We are AWS, we built on AWS, but we use Kubernetes on top of that. And Flyte, of course, is a main orchestrator that we use. And of course, AS3, and we also use all our machine learning is in PyTorch, and we use Carpenter and Ray for efficient utilization of resources. So now coming back to some of the problems before we had Flyte was that we were using normal scripts to kick off our pipelines, and there was no standardized way of kicking off a pipeline. We were running into a lot of issues on training data sets, keeping track of where in the process the pipelines are. And it was difficult overall to be collaborating as our teams were a team were expanding. We have a distributed team of data scientists and engineers across the multiple sites. So overall, it was causing a lot of issue about collaboration. So then we looked into different tools that are available. I looked at other tools. I was prior to this, I did have some familiarity with Airflow, but then when I looked at Flyte, I wanted something which is Kubernetes based, and we are since we are very familiar with Python, we decided to go with Flyte. So we really enjoyed working with Flyte, about especially around the uh, how Flyte has been set up and how we can scale this along with Kubernetes. So our Flyte is again based on is built on top of Kubernetes with S3, and we have some custom internal integrations. So the workflow steps, as I explained, is pre-processing, then we do training, then inference and reporting. So we use end-to-end of Flyte. We built on is built on the infrastructure is built on Flyte. So with the new setup, we are able to expand, run parallel experiments, multiple experiments at the same time. And with the integration of Carpenter, we're able to use the resources much more efficiently. And we have a mix of workloads. We have both GPU and CPU workloads. Further, within the GPU, we use multiple generations of CPUs depending on the type of experiments we are running. Some of those are old but gold kind of thing, where the models have been there for a long time, but those that have been validated. So we need to be able to support them as well. So the idea of using disparate compute resources and be able to configure and use them within Flyte is one of the key features that I like, right? Further, the it's essentially, since Python, it's built on Python, it's Python first. Our team has no issues be able to write Flyte scripts instead of mucking around with bash scripts or shell scripts or anything like that. And be able to kick off jobs without much help from machine learning teams. Our data scientists can kick off their own jobs, which has been a clear winner for us. Yeah, so again, the team is able to run faster experiments, right? And on the other side, we are able to get good feedback to when jobs fail, which can, of course, I'll go into. There are some features that might be helpful more, but overall, we're very satisfied with how Flyte is helping us. Of course, needless to say, any new technology brings up with its own challenges and lessons. So one challenge that we had definitely was that our team it's a new tool, and it took some time to get used to learning and using the Flyte system. But once we got a hang around it, I think now our team is much more comfortable. So So there are few things allow to be improved. One main feature, one pain point definitely is that we use custom Docker containers. So, but then when we are trying to test it locally, it it ignores the Docker images and runs locally. So what happens is that there are some things that run locally fine, works fine on my machine, but when we run in the cluster, it starts failing. Right. So request Flyte team to maybe see how we can we should be using the Docker image that I supplied instead of running locally. Right. The again error visibility is good, but can be improved because currently, if a job it's for if there is a resource mismatch in the backend and Kubernetes is in the pending mode, it still shows that in the front end it looks as if the job is still running. Right. So that's a so unless somebody logs into the Kubernetes cluster and maybe open up a K9s or something, you will know that the job is in pending mode. GPU support is again can be improved in the sense that there's a as I said, we use some custom specific GPUs to run some certain loads. So to specify that specific GPUs, uh, uh, there is again a mismatch between what Carpenter advertises as the GPU and what what Flyte adds as a taint or a toleration. Right. On that aspect, the taints and tolerations, there's a whole lot of boilerplate code that needs to be stuck in to just add a taint or a toleration. Maybe that can also, and there's a better way. Might be able looking for better solutions for that as well. Right. Yeah. Uh, what's next? We are definitely we're expanding into more disease areas, and we are bringing in more and more data. So definitely, the our Flyte usage will only go up, right? And we definitely want to take advantage of new features that Flyte provides, like caching and map tasks, right? And allowed to be part of this community and be able to share our findings as well as in the future any custom development that we do on Flyte that we love to share with the ecosystem. And a shameless plug here, we are hiring machine learning engineers as well as ML ops engineers. So if you're passionate about healthcare, solving uh, uh, massive problems in healthcare, as you know, and healthcare is one of the few areas where AI can, I believe, I've been in the industry for the last 25 years in healthcare. So I believe that AI definitely will help in, in either helping improve the outcomes on the healthcare. So if you have, there's a lot of challenging problems to solve in healthcare, right? For example, this pathologist workflow that we just went through, for each slide, they take around 4 to 6 hours to really uh, come up with their diagnosis. But AI can really assist them in speeding up those processes, right? So those are the type of problems we are, as I said, we are working on other disease conditions as well. And yeah, come join us, right? So, uh, and that's it. But please let me know if you have any questions. You can also please connect with me on my LinkedIn at the bottom, or you can send me an email as well. My email address is provided. Right. Thank you.
Awesome. Thank you, Radnakar. Um, that was a lot of very useful information and definitely a use case that I really love. So yeah, for anyone, feel free to drop your questions in the chat, whatever you're watching, either on LinkedIn or YouTube. Whatever you post in the comments, we can see it here, and I can ask questions. I had a couple of them in the meantime because I didn't see any from the audience yet. You mentioned one of the challenges was you had to build internal tooling for Flyte, or at least adapt internal tooling for Flyte. I don't know if you could add some details on it because I think this is really important and probably a good learning for anyone out there in the journey of adopting Flyte, and probably something we could ease if it's possible.
Yeah, for us, so some of the the storage, because the data that we are dealing with uh, each image is like gigabytes in image. So whenever so it's not easy for us to leave alone, let alone move from one cloud provider to the other. But moving from one region to the other itself is a big issue, right? So data movement is where we focused on, and how do we our partners the data that's there in their storage to be able to pull and provide that as inputs to our. So it's we build tooling around movement or storage, file storages, file movement around different regions, and be able make it available to our flight cluster. Mhm.
Okay. And okay, so this is because probably you have I don't know, image providers in different locations,
Yeah,
and you need to somehow move the data to
to
place
appropriate.
where I can read it. Okay,
Yeah, yeah.
that makes
And
sense.
also because of the of course we won't have this issue, but we designed it so that because in the we are currently everything is US based, but we are going international as well. So and because of this healthcare data, we need to we it's region specific and data sovereignty rules apply.
Okay,
So we need to take care of those as well.
got it. Yeah, thank you. The other thing was around taints and tolerations. When you say boilerplate code, do you have to use pod templates or anything like that to
Yes, we
apply?
use part templates, and yes, part templates and node affinity, right? So you need to specify those to, because we want to hit a certain node pool, right? So to specify all that, maybe yeah, might be a minor issue, but I don't want that. Maybe an easier way to do that instead of allowing data scientists to figure out all that, right? So,
Right. That reminds me of a discussion. Let me see. Yeah. Here I will drop this in the chat real quick. Hold on, please. There's a discussion in the RFC incubator. The RFC incubator is a category of discussions in the Flyte repo that folks can use to kind of again discuss a potentially massive change to the SDK before even writing an RFC or a proposal. It's a place to see what the community thinks. And yeah, I added the link, and probably I will share my screen. That essentially tries to reason about something similar. I mean, probably a higher abstraction. Because right
right.
now we have resort request, which is great, and probably it's the current direction. I mean, purely infrastructure. Or yeah, purely resources without any particulars to the underlying infrastructure or the cloud provider, CPU, memory, GPU, etc. This proposal tries to move a layer above, and there's some reasoning there. There are some examples of how some other Flyte users are using Carpenter also
Yeah.
uh, to achieve this. So probably it can be a
Yeah,
useful
yeah,
resource.
looks very wonderful. I'm just looking at it. Yeah, it makes a lot of, so yeah, definitely I would rather have the data scientist just define like, yeah, like this, like just a tag, and everything else gets in automatically. Uh,
Right.
yeah,
This
yeah,
is yeah. This is not implemented. Right. It's
yeah,
only
absolutely. Yeah, I understand. Yeah, yeah. This is just a RFC, but yeah,
it could help. All right. Stop screen. There you go. And the other one was yeah. When you mentioned you cannot use the same container image when you run locally versus remotely in the cluster.
yeah,
Um, yeah, I think we can explore this async because I think that is possible
I
in
see.
Flash. Yeah,
Oh,
you
okay.
could. I mean,
Because
yeah,
I read somewhere that it ignores the minus minus image when you run local. Yeah, but I might be wrong. Yeah.
you're using fast registration. I mean, PyFlight run or
Wi-Fi run. Yeah.
yeah, and you pass the argument of the container image, and it's ignoring the
Yeah.
image, right?
Yeah.
Mhm. Yeah, we might want to take a closer look at it because I think it should work. That shouldn't be an issue. And yeah, the rest is especially true. Yeah, when you need certain GPU models, you'd need to start dealing with things and tolerations. Probably a way to help with this. Probably you're already aware of this, but FlightKit already has a number of models that supports, and for each of these models, it automates the labels and taints and tolerations. But I feel that list needs to be maintained. I mean,
Yeah.
the
Yeah.
accelerators list,
Yes. Accelerators. Yeah.
accelerators. Okay. Yeah. I don't see any other question. So yeah, again, thank you so much, Radnakar, for your
Sure.
time. That was very useful. We plan to also write a blog post based on what you showed us today, so that should land in the flight blog. But first, you can review it, of course. And yeah, with that, thank you. Thank you so
Thank you.
much.
Thank you, David. Thanks for the opportunity. Thank you very much. Yeah.
Awesome. That was great. Have a
Yeah.
good day.
Yeah.